Good day, kids. I'm Mr. Alan De Lejero, your math teacher. Our lesson for today is about factors and multiples, prime and composite numbers. For Mathematics 4, Quarter 2, Week 1, our objectives. At the end of the video lesson, you are expected to, number 1, identify factors and multiples of a given numbers up to 100. Number 2, differentiate prime and composite numbers. Children, please get your module. Let's proceed. Activity 1A, identifies factors. Look at this illustration. How many rows of coconut trees are there? If your answer is 3, you are correct. How many coconut trees are there in each row? If your answer is 6, you are right. How many coconut trees are there in all? If your answer is 18, you are correct. To determine the total number of coconut trees in this figure, we can add 3 6 times. This gives us 3 plus 3 plus 3 plus 3 plus 3 plus 3 equals 18. We can also multiply. We can multiply 3 by 6, or in symbols, 3 times 6, the product is 18. Here, we refer to 3 and 6 as factors of 18. Factors refer to the numbers that you multiply to get the product. Are 3 and 6 the only factors of 18? If your answer is no, very good. Now, let's find other factors of 18. Look at this illustration. This illustration also shows 18 coconut trees. Here, we only have a single row. In a mathematical statement, we say that 18 times 1 is also equal to 18. Therefore, 18 times 1 equals 18. And 18 and 1 are also factors of 18. Look at this illustration. The illustration shows that 9 and 2 are also factors of 18. Now, these factors may also be written using a factor tree. 1 and 18 are factors of 18. We also have 2 and 9, and 3 and 6. So the factors of 18 are 1, 2, 3, 6, 9, and 18. Now, in writing the factors, we should write the numbers from least to greatest. As you have observed here, the factors of 18 are 1, 2, 3, 6, 9, and 18. Let us find the factors of 12 as the product of two numbers using the factor tree method. We have here 12 and the factors of 12, which is 2 and 6. Another one, factors 3 and 4, and we also have 1 and 12. The factors of 12, as I said, you have to write it from least to greatest. We have here 1, 2, 3, 4, 6, and 12. Let's proceed to exercise A under what's new. Give the factors of each number in your module. Okay, number 1 is 15. The factors of 15, we have here 1 times 15 equals 15. 3 times 5 equals 15. So the factors of 15 are 1, 3, 5, and 15. Let's proceed to number 2. Number 2 is 24. Look at this. 24, we have 1 times 24 equals 24. 2 times 12 equals 24. 3 times 8 equals 24. 4 times 6 equals 24. Then list down all the factors of 24. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. If your answer is correct, very good. Number 3. Number 3 is 16. We have 1 times 16 equals 16. 2 times 8 equals 16. And 4 times 4 equals 16. So the factors of 16 are 1, 2, 4, 8, and 16. Please check your answer. Okay, if your answer is correct, very good. Number 4, 36. We have 1 times 36 equals 36. 2 times 18 equals 36. 3 times 12 equals 36. 4 times 9 equals 36. 6 times 6 equals 36. And these are the factors of 36. We have 1, 2, 3, 4, 6, 9, 12, 18, and 36. Number 5, 21. We have 1 times 21 equals 21. 3 times 7 equals 21. And the factors of 21 are 1, 3, 7, and 21. Okay, we have here number 6, which is 32, and we are using the factor 3 method. So 1 and 32 are factors of 32. Another one is 2 and 16 are factors of 32. And we also have 4 and 8 are factors of 32. So 32, the factors of 32 are 1, you have here 1, then 2, 4, 8, 16, and 32. Number 7 is 45. So we have here 45, 1 and 45 are factors of 45. 3 and 15, or 3 times 15 is 45. 5 times 9 is also 45. So these are the factors of 45. We have 1, 3, 5, 9, 15, and 45. Number 8, 56. 1 times 56 is 56. 2 times 28 is 56. 4 times 14 is 56. 7 times 8 is 56. And 4 times 14 is 56. So these are the factors of 56. 1, 2, 4, 7, 8, 14, 28, and 56. Number 9 is 54. 1 times 54 is 54. 2 times 27 is 54. 3 times 18 equals 54. And 6 times 9 is equal to 44. And these are the factors of 54. We have 1, 2, 3, 6, 9, 18, 27, and 54. Number 10 is 72. 1 times 72 is 72. 2 times 36 is 72. 3 times 24 is 72. 4 times 18 is 72. And 6 times 18 is 72. We also have here 8 times 9 is 72. So these are the factors of 72. And let's start with the least number, which is 1, 2. These are the numbers 1, 2, or the factors of 72. 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. Let's proceed. Activity under what is it? Express each number as a product of two factors. Give at least two pairs of factors. So we have here number 1, 20 is equal to 2 times 10. 2 times 10 is 20. And 4 times 5 equals 20. So you are asked two pairs of factors. Let's begin with number 2. Okay. Here are the answers. For number 2, we have here 15. 1 times 15, 3 times 5. For number 3, 24, we have 1 times 24, 2 times 12, or 3 times 8, or 4 times 6. And number 4 is 28. We have 1 times 28, 2 times 14, or 4 times 7. Let's proceed to activity 2B. Identifies the multiples. Let us read the problem. Soledad visited her relatives who live at the right side of Ilang-Ilang Street in a Metro Manila subdivision. While walking, she noticed that the house numbers on the left are odd numbers, and the numbers on the right are even numbers. Soledad's relatives live in the 10th house at the right. What do you think is their house number? Let us help her find the house. Since the houses at the right side of Ilang-Ilang Street are even numbered, taking the 10th multiple of 2 will give you 20. Okay. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Therefore, Soledad's relatives live on house number 20. The sequence produced by the house numbers is an example of a set of multiples. A multiple refers to the product of a number multiplied by any of the consecutive numbers 1, 2, 3, 4, 5, and so on. For instance, the first 5 multiples of 8 may be described as follows. 1 times or 8 times 1 equals 8. 8 times 2 equals 16. 8 times 3 equals 24. 8 times 4 equals 32. 8 times 5 equals 40. Therefore, the first 5 multiples of 8 are 8, 16, 24, 32, and 40. In addition, multiples may be formed by adding the same number to the previous multiple. For example, 3 plus 3 equals 6, 6 plus 3 equals 9, 9 plus 3 equals 12, 12 plus 3 equals 15, and 15 plus 3 equals 18. So 3, 6, 9, 12, 15, and 18 are multiples of 3. Getting the multiples of a number is like skip counting with the same number. Example, the multiples of 2 are 2, 4, 6, 8, 10, and so on. Another example, multiples of 5 are 5, 10, 15, 20, 25, and so on. Let's answer activity A under what's new. Write the missing multiples of the first number in your module. I will give you 5 seconds to answer number 1. You have 6, blank, 18, blank, 30, blank. Time is up. The answer is 6, 12, 18, 24, 30, 36. Number 2, in 5 seconds. Time is up. The answer is 3, 6, 9, 12, 15, 18, 21. Number 3, 12 blank, 36 blank, 60 blank. Ready, start. Time is up. The answer is in red ink. 12, 24, 36, 48, 60, 72. Exercise B. What number is missing? Write the correct multiple for each number. 5 seconds only. Your timer starts now. Time is up. Answer is 54, and this is a multiple of 9. Okay, so 27, 36, 45, 54, 63. Number 2. 16, 20, blank, 28, 32. This is a multiple of blank. And the answer is 24. And this is a multiple of 4. 16, 20, 24, 28, 32. Number 3. 24, 30, 36, blank, 48. This is a multiple of blank. The answer is 42. And a multiple of 6. Number 4. 50, blank, 70, 80, 90. This is a multiple of blank. If your answer is correct, you've got it right. Answer is 60, and this is a multiple of 10. Number 5, blank, 30, 35, 40, 45. This is a multiple of blank. And the answer is 25. Multiple of 5. Let's proceed to activity 3C. Differentiates prime and composite number. Prime numbers have exactly 2 factors, 1 and the number itself. Examples: 7 equals 1 times 7. You will notice that 7 has only 2 factors, 1 and 7 only. 7 can be divided exactly by itself and 1. Therefore, 7 is an example of prime numbers. We also have 31 equals 31 times 1. Okay, you will notice here that 31 has only 2 factors, 31 and 1. The 31 can be divided exactly by itself and 1. So, 31 is an example of prime number. Let's proceed to activity 3C. Composite numbers are numbers that have more than 2 factors. 1 is a special number. It is neither a prime nor a composite number. Examples: 18, And these are the factors of 18. 1 times 18 is 18. 2 times 9 equals 18. 3 times 6 equals 18. And these are the factors of 18. 1, 2, 3, 6, 9, and 18. In this example, you will notice that 18 have more than 2 factors. So how many factors? We have 1, 2, 3, 4, 5, 6. So 6. That means more than 2 factors. The factors of 18 are 1, 2, 3, 6, 9, and 18. Therefore, 18 is an example of composite numbers. We also have 12. 12 equals 1 times 12. 2 times 6 is 12. 3 times 4 is 12. And you will notice that 12 have more than 2 factors. It has 6 factors. The factors of 12 are 1, 2, 3, 4, 6, and 12. So 12 is an example of composite numbers. Write P if the number is prime and C if it is composite. Number 1. If your answer is composite, very good. Number 2, 11. If your answer is prime, you got it right. Number 3, 10. If your answer is composite, you are correct. Number 4, 13. If your answer is prime, very good. And number 5 is 32. If your answer is composite, you are correct. Number 6, 23, and it is prime numbers. Let's proceed to the activity under what's more. We have here 100 charts. 100 chart, 1 to 100. So follow the instruction below. You are going to answer this following these steps. Step 1, encircle number 1. Step 2, encircle number 2. Put an X on all multiples up to 100. Step 3, encircle number 3. Put an X on all multiples of 3 up to 100. Step 4, encircle number 5. Put an X on all multiples of 5 up to 100. Step 5, encircle number 7. Put an X on all multiples of 7 up to 100. Step 6, list down all encircled numbers in order. These are called prime numbers. Step 7, list down all marked X numbers in order. These are called composite numbers? Let's take a look. The answers. Circled 1 is neither prime or composite number because it is considered as special number. Numbers in red ink and with X are examples of composite number. That means they have more than 2 factors. How about the encircled numbers? The encircled numbers are prime numbers. In 1 to 100, we only have 25 prime numbers, and the rest are composite numbers. Take note, 1 is not included because 1 is a special number. Remember, factors are numbers that we multiply to get the product. Multiples are the products of a number multiplied by other whole numbers. A prime number is a number with only 2 factors, 1 and the number itself. A composite number is a number with more than 2 factors. Children, are you ready for our assessment? We have letter A, complete the table in your module. And we have here example. The number is 5 and the factors of 5 are 1 and 5. So you write your answers here. The number of factors, okay, count 1, 2. So there are 2 factors. And answer is 5 a prime or composite? So the answer is prime. Why prime? Because it has only 2 factors. You may start now. Then letter B, give the next 4 multiples of a given number. Example, 2. So give the 4 multiples of 2. So 4, 6, 8, 10. Okay. We have 5 numbers. And letter C, write P if the number is prime and C if it is composite. Write your answers in your modules. Thank you, children. See you next time.